In number 1, we want to solve a quadratic, and we're going to first put it in standard form and see if we can factor. So I want 0 on the right-hand side, so let's bring over that minus x. So we have 6x squared plus x, and then bring over that 1 as a minus 1 on the other side. And let's see if this factors. Let's try 3x, 2x over here. Okay, we want a plus x in the middle, and here we have a minus 1. All right, so here we get minus 1 times 1 is minus 1. And then for the middle term, we have 3x and a minus 2x. That gives us a plus x in the middle. Okay, so this is the correct factorization. Then we set each factor equal to 0. And solve. So we have 3x equal 1, x is equal to 1/3, and 2x is equal to minus 1, and x is equal to minus 1/2. So those are our two solutions. Okay, here we have another quadratic. Let's try factoring. All right, we'll put 2x over here. All right, we want to get a minus sign in the middle. Okay, this is a plus, so these are both going to be negative, 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 same sign, and it's minus because of that. Okay, and we want to get that minus 9 in the middle, so let's try 5 times 2. Check the middle term, we have a minus 5x and a minus 4x. That gives us that minus 9x in the middle. Okay, so this is the right factorization. And again, set each factor equal to 0. So here we get 2x equal 5, x is equal to 5/2, and here we have x is equal to 2. So those are our two solutions. In number 3, we are not going to solve by factoring because we can easily put this in the form something squared equal to a number, and then take the plus minus square root of both sides. So that would be the fastest way of solving this because of the form that it's in. All right, so let's add 4 to both sides. So we have 3x plus 1 squared equal to 4. And now plus minus square root both sides, and we have 3x plus 1 is equal to plus or minus 2. And let's split this up into two equations and solve. So here subtract 1 from both sides and divide by 3. So there's one solution. Here again subtract 1 and divide by 3. So there are our two solutions. All right, let's try the same thing in number 4. Okay, so we bring over the 5 to the other side as minus 5, plus minus square root both sides. All right, on this side we're going to get a complex number, square root of minus 5. Let's rewrite that. Let's rewrite it as I square root 5. All right, and so we have 2x is equal to 1 plus or minus I square root 5. And now divide by 2, and x is equal to 1 plus or minus I square root 5 divided by 2. All right, so we have two complex solutions. In number 5, we will set equal to 0, get 0 on the right-hand side. And we can easily factor this, just pull out an x. So we have two solutions, x equals 0 coming from the x factor, and from here we have 2x equal 5, and x is equal to 5 over 2. All right, number 6, we're solving by completing the square. So let's set this up, bring the 2 over to the other side as a minus 2. and we're going to put in our blanks. And now we fill in with half the middle term squared. So half of 10 is 5, squared is 25. This is now a perfect square. Let's factor that. It's x minus 5 squared. And here on the right-hand side we have 23. All right, so now we can square root both sides, plus minus square root. So we have x minus 5 is equal to plus or minus the square root of 23. And we have x is equal to 5 plus or minus the square root of 23. All right, and number 7 we'll solve using the quadratic formula. All right, let's just write that x is equal to negative b plus or minus the square root, b squared minus 4ac over 2a. So in this case we have negative b, that would be minus minus 5, plus or minus the square root, b squared minus 4ac over 2a. All right, so let's just work this out. So here we have 5, plus or minus the square root. Here we have 25. And multiply this out, and we have plus 80 over 4. Okay, so that's equal to 5 plus or minus the square root of 105 over 4. So there we have it, 2 irrational solutions. In number 8, we want to calculate the discriminant of each of these quadratic expressions and determine the type of roots. So the discriminant is the expression b squared minus 4ac that's underneath the square root in the quadratic formula. Okay, so let's look at a. Let's calculate b squared minus 4ac. So b squared, that would be minus 4 squared minus 4ac. All right, so here we have 16 minus 16, which is 0. If the discriminant is 0, that means the quadratic is a perfect square. It factors as a perfect square, so it's going to have 2 roots that are rational. All right, let's see. Let's factor 4x squared minus 4x plus 1, and we have 2x minus 1 times 2x minus 1. Okay, so that's how that factors 4x squared. Then we have a plus 1, and we have a minus 4x in the middle. So you see these are the same. So from these two factors, from the first factor we get that 2x equal 1, and we have a root of 1/2. And from the second one also root of 1/2. All right, so what happens here is we only have basically one root, one root, and it's rational. It doesn't contain a square root. It's rational. One rational root. Okay. So when b squared 4ac is 0, okay, 0 for b squared minus 4ac, that implies one rational root. All right, let's look at b. Okay, so here we have our quadratic b squared, that's minus 2 squared minus 4ac, 3, 1. That's 4 minus 12, negative 8. That means underneath the square root we have a negative, which means that we have complex roots. All right, so negative implies 2 complex roots. Let's look at c. 5x squared plus 10x plus 1. Okay, let me copy that here. 5x squared plus 10x plus 1. So b squared, that would be 10 squared minus 4ac. Okay, so we get 100 minus 20, which is 80. Now 80 is not a perfect square, so our quadratic, our solution is going to contain the square root of 80 as part of the solution to the obtained by the quadratic formula. All right, so we have something that's positive and not a perfect square. So we have two real roots. If it was a perfect square, we'd say two rational roots. Let's see what d is. And so d is x squared minus 4x minus 5. Okay, b squared minus 4ac. So there we get 16 plus 20. So we have 36. Now this is a perfect square. And that means that the original factors, and that we have two rational roots. So perfect square, that means two rational roots, no square root in our solutions. Now here we have what we called another type of equation. This is a fourth degree polynomial. So first we try factoring to solve. First set equal to 0 and factor. So let's first subtract 15x squared from both sides so that we obtain 0 on the right hand side. And now we can factor by just pulling out x squared. And then we can factor this quadratic further, so let's do that. Okay, so we have x plus 5, x minus 3. So we get three solutions, x equals 0, x equal minus 5, and x equal to 3. Well, here we have x cubed minus 8 equals 0, so we can simply take the cube root of both sides, solve for x cubed, and take the cube root of both sides. Or we can say raise both sides to the 1/3. And we have x is equal to 1. In number 11, we're going to clear out the denominators. All right, notice that the denominator on the right-hand side factors into x plus 4 times x minus 4. Since we have these factors in the denominator, let's note that x can't be equal to 4 and x can't be equal to minus 4. So now we're ready to clear out the denominators, and we'll multiply both sides by the product x plus 4 times x minus 4. All right, so maybe I'll just rewrite this. Times x over x minus 4 minus 4 over x plus 4 okay, that's one side. 8x, and here we have x plus 4, x minus 4. And we're multiplying by x plus 4, x minus 4. Okay, this cancels. When we multiply through, these x minus 4's cancel, and we get x plus 4 times x minus, and now the x plus 4's are going to cancel, and we have x minus 4 times 4 equal to 8x. Multiply through, x squared plus 4x. Be careful with the negative here. We'll multiply by minus 4, so we have minus 4x. And then here we have a plus 16. Okay, so we have x squared plus 16 is equal to 8x. Let's subtract 18 from both sides. If we factor this factors as x minus 4 times x minus 4. So we get the one solution x equal 4, but remember we said in the beginning that x cannot equal 4, so we cross this off and we conclude that there's no solution. In number 12, we're going to solve by cubing both sides. All right, we'll do that to get rid of that cube root. So we have 3x minus 1 is equal to 125. And 3x is equal to 126. Divide by 3. And we have that x is equal to 42. We have to check when we square both sides. Here we cube both sides, so we don't really have to check here. I mean, you could just to be on the safe side, but really we have to check when we square both sides. Okay, here we have a radical equation, and we're going to start by isolating the radical. So let's add this square root to both sides, and we have x is equal to square root 6x plus 7. So now the radical is isolated on the right-hand side, and now we're ready to square both sides. And remember, when we square both sides, we must check our solution. So on this side, we get x squared on the left. On the right, we get 6x plus 7. All right, so let's put this resulting quadratic in standard form. And let's factor. Okay, so it factors into x minus 7x plus 1. So we end up with these two solutions, x equals 7, x equals minus 1, or two potential solutions. And now we must check. So let's start with x equals 7, substituting into here. And we have, 7 equal to, and on the right-hand side we have 42, 6 times 7, 42 plus 7. So 7 is equal to the square root of 49. So this is a valid solution. And now let's check x equal minus 1. Again, into the original. So we have minus 1 is equal to the square root of negative 6 plus 7. Or minus 1 is equal to the square root of 1. Which is not true. So this is not valid. So we only have one solution, x equals 7. All right, here we have in number 14, again, a radical equation. Let's isolate the radical. Well, it already is isolated, so we're up to the step of squaring both sides. On the left, we have 3y plus 1. And on the right, we're squaring y minus 1 times y minus 1. So we get y squared minus 2y plus 1. Let's put this in standard form. And we're going to subtract 3y from both sides. That'll give us a minus 5y. And subtract 1 from both sides. We can factor out y. And we get two solutions, y equals 5, y equals 0. And now we must check. So first we'll check y equals 5, substituting back into this original. All right, so we have square root. 3 times 5, 15 plus 1, that's the square root of 16. Is that equal to 5 minus 1? All right, well, yes it is. Square root of 16 is equal to 4. Okay, so this is a valid solution. All right, now let's check y equals 0. Back into the original. So we have the square root of 1 is equal to minus 1, which is not true, so this is not valid. So here we have one valid solution. Number 15 is a little more complicated because we have two radicals. So first we isolate one of them. Well, one of them is already isolated, so we're ready to square both sides. On the left, we have 2y plus 9. On the right, well, let's just write this out, what we have to square. We're going to multiply 2 plus square root y plus 1 times itself. All right, so here we have 4. Middle term is 2y plus 1 times 2y plus 1. That's 4 square root y plus 1. And then last term is square root y plus 1 times square root y plus 1, and that would be y plus 1. Okay, so let's simplify this. Well, first let's isolate. We're going to isolate this radical and square again. So on the right-hand side, we have 4y plus 1. We actually isolate the radical term. We can have that coefficient in front. All right, here we have a 5. Let's subtract 5 from both sides, so that'll give us a 4. And we have y. Subtract y from both sides, and we have y plus 4 on the left. And we're ready to square both sides again. So we're going to square this. All right, so on the left we have y squared, and the middle term is 4y plus 4y. That would be 8y, plus 4 times 4 is 16, equal 4 squared is 16, and when we square this radical we get y plus 1. All right, let's multiply out on the right. So we have 16y plus 16. Let's just subtract off the 16 from both sides. Subtract 16y, and we have y squared minus 8y is equal to 0. Factor out y. And we have two solutions. Y equals 0, y equals 8. Let's do our check over here. First, y equals 0. Let's look at that original. We're substituting right into this. Substitute y equals 0, and we have square root 9 is equal to 2 plus square root 1. And that does check. That's 3 is equal to 2 plus 1. Okay, that checks. Let's try now y equals 8. Again, into this original. So here we have square root of 16 plus 9. That is square root 25. And we want to see, is this equal to 2 plus? And we're substituting 8 square root 9. Okay. So that's 5 equal 2 plus 3. Yeah, that also checks. So both are valid solutions this time. So this time we have two solutions, y equals 0, y equals 8. All right, number 16, we want to open up this set of parentheses by raising both sides to the reciprocal of 3/2. That is 2/3. Raise both sides to the exponent 2/3. Okay, so here, raised to the 2/3, and on the right, 27, raised to the 2/3. On the left, we have 2x plus 1. On the right, we first do the cube root of 27, which is 3, and then square it to get 9. Let's subtract 1 from both sides and divide by 2. And here's our solution, x equals 4. In number 17, start by isolating this term. Add 1 to both sides. So we have 3x minus 1 to the 2/3 is equal to 9. And now we're going to raise both sides to the 3/2, and this is the case where we have to be careful, because when we raise to the 3/2, what we're doing is cubing both sides and square rooting. So when we square root, in order to get both possible solutions, we must take plus minus on the number side. Okay, so that's because of the 2 in the denominator. Basically, we're square rooting both sides. We take the plus minus square root. All right, so here we get 3x minus 1 is equal to plus minus, and here we first do the square root of 9 is 3, and 3 cubed is 27. So we have these two equations. 3x minus 1 is equal to 27, and 3x minus 1 is equal to negative 27. Add 1, and we have 3x is equal to 28. So x is 28 divided by 3. And here add 1, and we have 3x is equal to negative 26. And x is equal to negative 26 divided by 3. Two solutions. In number 18, we have what we call a quadratic-like equation. Notice that when we square the middle term, if you square square root of x, you get x. So that's how we recognize that it's quadratic-like. We put y equal to what we have in the middle without the constant in front, without the coefficient. Y is equal to square root of x. So y is the middle variable expression. Okay, if we do that, x, notice, is y squared, and we get the quadratic y squared minus 3y plus 2 equals 0. And now factor. Okay, this factors into y minus 2, y minus 1, and we get these two solutions. So these are y solutions. In order to get the x solutions, we have to replace y with square root of x. All right, square both sides. So here we get x equal 4, and here square both sides, we get x equal 1. Notice since we squared both sides, all right, to go from here to here, we squared both sides, so that means we must check. You can always check just to be on the safe side, but in this case, it is possible that we have a non-valid solution. So we'll start with x equal 4 into the original, and we have 4 minus 3 times square root of 4, 3 times 2, plus 2, and we want to see is that equal to 0. All right, so that's 4 minus 6 plus 2 is equal to 0. So that one checks. And then we try x equal 1. And we have 1 minus 3 plus 2, and that is also 0. So we have two valid solutions.